talk about is basically two different data sets. We monitor 4 sites up by the river, these 2 sites in the middle of the lake, and then out by the channel. And these 2 sites, sites 2 and 3 for AWRI, also correspond to the MyCore data that have been collected over the last 10 years. That's a volunteer monitoring effort done by the state of Michigan, funded by the state of Michigan, and then the data sets are available to everybody. So I'm going to first talk about our data that we've collected this year, and then talk about how that corresponds to the other data. So, and I'm sorry for the size, so bear with me. I'll do the best I can to explain this. What you're going to see in these graphs are pretty much the same format. We have the parameter of interest along the y-axis, which in this case is temperature, and then time during 2024. And we have 8 different lines. The orange lines represent surface sites from site 1, which again is the channel, down to site 4, which is the river. And then the blue and black represent the bottom, because we sample both at the surface and at the bottom at these 4 different sites, right? And temperature does exactly what you'd think. It kind of warms up in the middle of the summer, and then as we get out towards the end, we stop sampling in mid-October, it declines, and the bottom temperatures are cooler than the surface temperatures, as you'd expect. And then over on the right is dissolved oxygen, which we know is very important for the biota in the lake. And again, at the top, the surface, the orange, represents relatively high, 9 to 10 milligrams per liter of dissolved oxygen. You want to be above 5. 5 is really where the limit is for most of the fish of interest. Below 5, you start getting either no fish or trash fish that you're really not that interested in. And if you can see here at the bottom, sites 2 and 3 in the middle of the lake, in the midsummer, our oxygen concentrations go down to less than 1 milligram per liter. We call that hypoxia, and potentially anoxia, where there's virtually no oxygen. We are seeing the same exact thing in Muskegon Lake. This is not unique to White Lake. The question is, and we haven't been able to resolve this yet, is whether this is due just to the morphometry, the shape of the lake, where basically these drowned river mouth lakes, like White Lake is, they have the water that just sort of settles in the middle of the lake and it doesn't move very quickly on the bottom. And so there's an opportunity for all of the microbes to suck out the dissolved oxygen, because they're still respiring. And then there's no oxygen getting from the surface down to the bottom because the lake is stratified. Or is it because of all the organic material that's been put into these lakes over years? Because White Lake and Muskegon Lake, we know, have had a lot of organic matter introduced. And now the microbes have a lot of organic matter to respire, and that's what's causing the respiration and the dissolved oxygen to go down. We don't know that, but this is cause for concern, all right? If there's one thing that I think comes out of our monitoring this year is that we have to be aware that the middle of White Lake in the summer, in the midsummer, potentially goes anoxic. So there's a problem with potentially for the fish, and also, secondarily, when the bottom sediments go anoxic, what happens is the iron that's present there naturally in the sediment, it normally binds to the phosphorus and it keeps the phosphorus in the sediment, well, as long as there's oxygen. But when there's no oxygen, that iron becomes chemically reduced and it releases that phosphorus, which then can bleed out of the sediment up into the water column and stimulate algal blooms. So that's another potential concern. So something to keep your eyes on, and as we continue monitoring, we'll make sure we continue looking at that as well. In this case, we're looking at total phosphorus. This is another parameter that we're very interested in. We want to make sure it doesn't get too high. And you can see at one site here, this site is site 3. At the bottom, the phosphorus concentrations remain relatively high. We don't have the last few months of data yet, so I'm sorry, this only goes up to about July. But we want to stay, in fact, I think this is the restoration target that was established for the phosphorus BUI in White Lake. It was 30 micrograms per liter. And we can see that several of the sites do exceed the 30, which is problematic. Now, all these sites, the surface tends to be below 30, but at the bottom, it can go above 30. Again, that might be to that phosphorus coming out of the sediment, what we call internal loading. Sorry for the technical terms, but it might be responsible there, and that might be related to the low oxygen levels. Does that make sense? I want to make sure everybody's following this. If not, let me know. And then on the right is soluble reactive phosphorus. This is the dissolved form of phosphorus that's taken up by the algae, the bioavailable form. And We would like to stay below 10. You can see you're above 10 on some of the bottom sites. Again, that's probably phosphorus coming out of the sediments. And so we'll also keep an eye on this. And we'll also see, probably within a month or so, I'll have the phosphorus data for the last 3 months and know whether this persists through the summer or whether it starts to decline as we go into the fall. This is nitrate. And nitrate, we like to be below 1 milligram per liter, so you're well below that. But what you also see, I want to point out that, hopefully this is animation, yeah. The highest concentrations are up around site, the river site. And that's probably coming off of the farms above the lake, right? Because nitrate is the main fertilizer being applied to cornfields, to maize fields, to soy fields. And so that nitrate can leach out of there, but it's still not exorbitantly high, and that's the good news. But again, it's something to be aware of. And then this is ammonia. This is the reduced form of nitrogen. And again, we want to stay below about 1 milligram per liter, which we clearly are here, except for this one site, site 3 at the surface. I don't know what was going on in the spring. It could have been some sort of release off somewhere off the land around where site 3 is. Just don't know, because it was one particular sample. It was ephemeral. We didn't see it continue. But sometimes, somebody might be releasing something, and that might account for that kind of high concentration. But when it's a one-off, I don't worry about it too much. Chlorophyll A, this is the pigment that gives you an indication of how much algae are present in the lake. And the BUI restoration target was 10 micrograms per liter. You can see, particularly sites 2 and 3 in the middle of the lake, we're seeing more chlorophyll. This might be a result of the more phosphorus that we see coming in those sites. So at times we're getting blooms. Now, we got blooms in every lake this summer in West Michigan. It's not unique to White Lake. I'm not trying to minimize this problem, but I'm also saying it's not unique to White Lake. It was warm, it was calm, and it was just right conditions for blue-green algae to grow this summer. The good news is, and I don't know if it's in this next slide or not, yes, it's microcystin. This is the main toxin that blue-green algae release, and for recreational water bodies like White Lake, the EPA target is less than 8, and you're down at 1.2 is your highest. So you have microcystin, but it's not at concentrations where it can create any kind of health problems. So that's the good news. Now what I want to do is, what we see here actually this should go, 2013 to 2023 is the MyCore data. So again, for total phosphorus, remember our limit is 30, that's the restoration target. And you can see how the data bounced around. This is just sites 2 and 3 in the middle of the lake, and then the data that we have so far in this year. So you're in the boundaries of what you've seen historically. It hasn't gotten much better, but it hasn't gotten much worse either since delisting. And then I have the same thing for chlorophyll, where you have the historic data from 2013 up to 2024, and then since then, what we see is that we're a little higher, but we're also low at times as well. So again, within those general bounds. So in conclusion, what I want to say is that the water quality in White Lake is good. It's stayed relatively similar to what we saw prior to in the last 10 years. There's been no consistent improvement or degradation for phosphorus and chlorophyll BUI since the delisting. And then some issues to be concerned about or aware of for the future: the low dissolved oxygen in the bottom waters in the middle of the lake during the summer, the high nitrate coming down from the river, and E. coli concentrations, which I did not show, but also just at the river site are a little higher than we'd like. Still not above any kind of state standards. You're still below that, but they're higher than we see in the rest of the lake. And then, as Jim's going to talk about, there's a buoy that's going in. I just want to briefly talk about the buoy that we have in Muskegon Lake, which your White Lake buoy will try and emulate, although perhaps not to the same degree of parameterization. Our buoy sits in about 40 feet of water in Muskegon Lake, in the middle of the lake. It's very well instrumented. We have every 3 or 4 meters a series of these different sensors that's measuring all sorts of water quality as well as temperature. We have an acoustic Doppler current profiler which measures water flow in 3 different directions, and it's relaying data back every 30 seconds. And then this is just one example of dissolved oxygen concentrations. We take it out in November or early December. It used to be for fear of ice. I'm not sure we need to take it out anymore since we don't really get ice in Muskegon Lake. And then we put it back in April. So that's where the data gaps are. But you can see for the 4 different depths where we have dissolved oxygen meters, just like White Lake, it goes down to near 0 in the middle of the summer, right? And again, just not sure if that's anthropogenically related or whether it's a natural phenomenon. And that's something we need to identify. So the advantage of the buoy is we're getting much more robust temporal data every 30 seconds instead of 3 or 4 times a year, which is great. But it's only in the middle of the lake. You're only getting 1 site, right? Whereas when we sample the lake, we're getting all 4 sites along the longitudinal depth gradient of the lake. And there is a nitrate sensor that is made, but it's very expensive and it gets biofouled very quickly, so we usually don't get any nutrient data off of this. If people are interested, they go to our website at AWRI and they can look up all the buoy data that you ever wanted. It's all available, it's all free, it's all downloadable. And then we also create this dashboard from the data that we collect on Muskegon Lake, and we'll do the same for White Lake once we finish collecting all our data. Where at the top, this is now 2022 total phosphorus in the middle of the summer. A restoration target, just like White Lake, is 30 micrograms per liter or parts per billion. Back in 2022, we were just above where we would like to be for meeting the goal. We were at about 32 micrograms per liter. But also we have the historical data. So back in 1972, EPA, as part of the Clean Water Act, measured White Lake, Muskegon Lake, and Mona Lake to see what the conditions were. So we have historical data that we can use for White Lake to see what it was like back then. The phosphorus concentrations were 60 to 70 micrograms per liter. Remember, our target is 30. So they were much higher. I can't remember offhand what White Lake is. I meant to look at that, and I apologize. But then we can look at how things have changed over time. And they've improved in Muskegon Lake. Once we started sending the effluent, instead of into the lake, we sent it to the Muskegon County wastewater treatment system, same as in White Lake, the conditions improve. And that's one of the main reasons why the nutrient concentrations have declined so much in White Lake. Of course, you still had the contaminated sediments from Hooker and DuPont and Tannery Bay, but those have also been dealt with thanks to EPA funding. So with that, I think I'm gonna turn it over to Jim. Oh, I just want to thank the funding sources, some of the folks in my lab that did a lot of the work here. And with that, I'll turn it to